Hello good day viewers. In today's tutorial we are going to see the kinematics. So before moving to kinematics, what is kinematics? Kinematics describe how object moves without reference to force. So let's talk about the scalar and vector. So let's see the scalar and what? And vectors. So what are scalars and what are vectors? Scalars are the one that has what? Magnitude but no direction. But why vectors has both what? Both magnitude and direction. It has magnitude but no direction. Why it has both magnitude and what? And direction. So what are scalars and vectors? Mass is what? Mass is a scalar quantity, and therefore distance is also a scalar quantity, and also what? And also temperature is also a scalar quantity, and speed is also a what? Speed, it is also a scalar quantity. So what of the vector quantities? In vector quantities we have what? We have displacement, and therefore we have what? We have velocity, and we have acceleration, and therefore we have momentum and rest. So in this scalar and vectors, one thing that I need you to know is that the difference between what? Between the distance and what? And displacement. So displacement is the same thing as what? The final position minus what? Minus the initial position. So suppose, let's say a person, let's say this is a person, it is moving what? Toward east of at what? At let's say 100 what? Let's say 100 meters, and okay, let's make it small amount of number. Let's say 10 meter, and therefore it's moving opposite the direction that he moved. After he moved east, so then he moved what? He moved to west. Let's say he moved to west at what? At 7 meter. You all know that the direction that is going through the west is what? Is negative. So let's say I am asked to find what? To find the distance. So to find the distance, I will say the distance should now be equals to plus 7, which should now be what? 17 meter. So what if I am asked to find the displacement? So the displacement should now be what? The final is 10 minus what? Minus 6. I have to say plus what? Plus negative 7. So this should now be equals to what? This should now be equals to 3 meter. So what I need you to know here is that displacement, it has direction, but distance, it has no direction. As you can see, I indicate the distance that what? That the person move again toward what? Toward the west. So therefore I identify what? I identify the direction, because because this direction that is going here, it is what? It is negative, but where the direction that is going here, it is what? It is positive. So this is all I want you to know. So there is next thing that I need you to know, the difference between speed and velocity. So we have speed, we have instantaneous speed, and therefore we have average speed. So what is average speed? The average speed is, it is equals to what? It is equals to distance over what? Over time. And therefore what is the average what? Average velocity. Average velocity, which is what? Which is displacement over what? Over time. And you have to understand that speed, it is always what? It is always positive. But why velocity, it can be positive, and also it can be what? It can be negative. So this at the end, I will say the instantaneous, the average velocity, this should now be equals to, we all know that displacement, which is what, the final position minus the initial position. So this should now be what, the final minus what, minus the initial, divided by what, divided by the value of what, of time. Let's say suppose I am given a distance, let's suppose I am given a distance of 10 meter, and therefore I am given the time as what, as 5 seconds, and therefore again I have to say I'm given two distance, or let me say I'm given a distance of moving toward this as 10, and therefore I'm given the distance toward this as what, as 5. So this should now be what, let's say 10 meter, let's say what, let's say 5 meters. What will be the distance, the average what, the average speed of this? So this should now be what, s, it is equals to distance over what, over time. So this should now be equals to, I have to say this 10 meter plus 5 meter, it will give me what, it will give me 15 divided by the value of time, which is what, let's say the time, it is what, it is 5 seconds. So this should now be 5. So if I said 5 here, it will give me what, 3. 5 here, it will give me what, 1. So this should now be equals to 3 over 1, and therefore what, the average speed, which is equals to what, which is equals to 3 what, meter per second. But if I am to find the average velocity, this should now be equals to what, the final minus what, minus the initial divided by the value of time. So this should now be equals to 10 plus minus 5 plus minus 5 divided by the value of time, which is what, which is 5. So 10 minus what, 5, which is 5 divided by 5. This should now be equals to here 1. So therefore I have what, 1 meter per second. So this is one of the difference between speed and what, velocity. Speed and velocity is the same thing as, let's say, distance and what, distance and displacement. And you have to take note that the average speed is not equals to what, the average velocity, but you have to note that the speed, the instantaneous speed, is the same thing as what, as the magnitude of what, of instantaneous what, instantaneous velocity. And sometimes we might have the change in x. So this should now be x of f minus so minus x naught. So again, let's see some formulas under the constant speed and constant acceleration. So in constant speed, we all know that the displacement, it is equals to vt, and therefore what, also the displacement, it is equals to what, the average multiplied by what, by the time. And also velocity, it is equals to what, the average what, average what, average velocity. The instantaneous velocity, it is equals to average velocity. But why in constant acceleration the instantaneous velocity is not equals to what, the average what, average velocity? And we have to take note of distance is the same thing as the x, the position, the final position minus what, minus the initial position. But why in constant acceleration the average velocity, it is equals to what, it is equals to v naught plus what, plus b final divided by what, divided by the value of what, divided by the value of 2. So this is showing that this is the same thing as saying a half multiplied by v naught plus what, plus the final what, final velocity. And you have to take note that we say the distance is the same thing as v and what, v and t. So I have to substitute. What should I going to do? So this is the same thing as saying the distance should now be equals to the vt. This is the, what is the value of vt? Value of vt is complete this. So therefore I have to say a half of what, of v naught plus what, plus bf, which is the final, multiplied by what, multiplied by t. So therefore this is what, this is an equation that you will use for what, for displacement. maybe in an equation of motion, in some example you might ask to find what, to find the displacement, and you might be given what, the initial velocity, and therefore you might be given the final velocity, and time will be given. So therefore this is what, this is a formula. You can keep it down so that you will use them in what, in calculations. Also the average velocity is the same thing as the what, the final position minus the initial position divided by the value of what, divided by the value of time. So if I am to find the value of xf, this is something as saying the xf minus what, x0, it is equals to what, it is equals to what, it is equals to vt. Xf shall now be equals to, I have vt, or let me say this shall now cross the equal sign, it will become x0 plus what, plus vt. So this is another what, another relation formula that you might use. You might use it in what, that you might use in solving what, some problem under equation of motions. And also you have to take note that the average acceleration also the same thing as what, the v final minus what, minus the v initial divided by what, divided by the value of what, the value of time. So as here, if I cross multiplied, I am to find the value of what, the final velocity. So this should now, this is something as over 1. So I will have the final velocity minus the initial, it is equals to what, it is equals to 80. So this final should now be equals to what, when this cross the equal sign, it will now be what, v0, it is equals to plus what, plus 80. In some equations you might see that v, it is equals to u plus what, u plus 80. So this is the formula. So you all know that this is final velocity, this is final velocity, and this is what, this is the initial what, initial velocity. And therefore it's the same thing as saying we have another relation, the final vf square, it is equals to v0 what, square plus what, plus 2ad. So this is another relation that you might use. In some of the formulas you will see that v square, it is equals to what, u square plus what, plus 2a what, 2ad. So it is all what, it is all the same thing. Or there is another relation that you can say that the distance is the same thing as v0 t plus what, plus a half a t squared. So these are some formulas that I have under the kinematics. So please, you have to take a look to these formulas, this one and this one, and those formulas. They are very important. Please kindly write them down. So let me see over there, I have some example. The question says a bus is traveling at a constant speed of 40 meters per second. How many hours will it take to travel a distance of 200 miles? So the velocity, which is 40 meter per second, and how many hours? So we are looking for time, but the time not in second, in hours, to traveling at a distance. So therefore the distance should now be 200 what, 200 miles. If you recall the formula that we say d, it is equals to vt. So therefore we are going to use this formula, but I have 200 miles. There is no way that I will say d, it is equals to vt. If I divide both sides by what, v will cancel vt, it is equals to distance by what, by the t, because this distance is in miles, but why the velocity is in what, meter per second. So therefore there is no way to use that, because I'm looking what, I'm looking for time in hour. So I have to convert meter to kilometer and kilometer to miles, and I have to convert second to minute and minute to what, to hours. So the first thing that I'm going to do, I have to take a look to the what, to the velocity. I have to say velocity, which is what, 40 meter per what, per second. So the per second, I have what, I have second. So therefore I have to multiply it by what, 1 kilometer, because I'm converting meter to kilometer. So therefore 1 kilometer is equivalent to 1000 what, 1000 meter. So 1 kilometer divided by what, 1000 meters. So as you can see, this meter will cancel what, this meter. So the next thing, I have to convert kilometer to what, kilometer to miles. So 1 mile is equivalent to what, 1.1 miles is equivalent to 1.60 what, 1.609 kilometer. So as you can see, the kilometer what will cancel the kilometer. The next thing that I have, which is what, which is mile. So I have to get away of this second. So we all know that 60 seconds make what, make 1 minute. So this will go with this, and therefore I have minutes. So therefore multiply by what, 60 what, 60 minutes make 1 hours. So as you can see at the end, I'm left with what, 1 miles per what, per hours, and this is what I want. So I have to say 50 multiply by 1 multiply by 1 multiply by 60 multiply by 60 divided by 1000 multiplied by this multiply by 1 multiply by 1. So therefore at the end I'll have what, multiplied by 1 multiplied by 1 again, which should now be 89.5. so therefore the velocity should now be 89.5 what, miles per hour. So as you can see, I can find what, I can find the value of what, the value of time here. So as I was saying that the value, I'm looking for the value of t, divide both sides by b, v will cancel v, and therefore t should now be equals to d divided by the value of what, the value of this t. So this is the same thing as saying the value of the distance, which is what, which is 200 what, 200 miles divided by the value of what, of 89.5 mile per hour. So as you can see, miles will cancel mile, I am left with what, hour. So therefore this should now be equals to 200 divided by answer, which is 89.5. So at the end, the value of the time, it is equals to 2.23 what, hour. So as you can see, we already find the solution of what, how many hour will take to travel a distance of what, a distance of 200 what, of 200 miles. So the next thing that I'm going to do here is that I have to take a look to the second question, which says that if the bus move from what, from a position that is 50 miles east of CTXYZ to a position that is 90 miles west of CTXY in 5 hours, what is the average velocity of what, of the bus during that time interval? So let me have some space here. Already I know that the velocity, which is 40 meters per second, and my new time, which is what, which is 2.3 hour. So we are talking about a bus move far away. So let me draw this. Let's say it move far away like this. It says from what, so therefore we have, let's say this is what, this is 90 miles, which is the final. Let's say this is what, let's say the position that is 50 miles east, this is east, and this is what, this is west. So therefore we have the west here, and therefore the east, let's say this is 50 what, 50 miles, which is what, the x initial. We have the x, y, and what, and z. So what next we did not have, and this should now be what, let's say 0 at the what, the center of what, of the x, y, and what, z. So we are asked to find what is the average velocity of the bus during that time. I have to take a look to this, my final, which is what, negative 90 what, miles, and therefore the initial, which is what, which is, I have 50 what, 50 miles, and also the time, which is what, which is 5 hours. So therefore I'm looking for what, the average velocity. So the average velocity, this should now be over time. So minus what, minus initial. So this should now be minus what, minus 90 minus what, minus positive 50 what, 50 miles divided by the value of what, which is the 5 hours. So this should now be, if I say minus this is something as saying 90 minus what? Minus 50 divided by what? Divided by 5. This is the same thing as what? 1 minus what? Minus 140 over what? Over 5. So minus 140 divided by 5, this should now be what? Minus 20 what? Minus 28 to what? Mile per hour. So as you can see, these are in miles, and therefore we have what? We have all it is in miles, and we have miles per what? Per hour, and therefore we have over, which is what? Per hour. This is the same thing as saying 28 what? Miles per hour. So this is the end of this kinematics. We see some formulas and examples. So don't forget to subscribe to this YouTube channel for more interesting video. Thanks you for watching. Have a nice day.